Cool. So we're doing 3.2 angle, side angle, and angle, side triangle congruence, or otherwise known as the ASA angle, side angle postulate, right? Or angle, side postulate. Cool. Basically, you can sometimes look at a triangle and say, hey, those two look the same. Great. And then if you're using technical terms, say those two triangles are congruent. But you can't necessarily prove it unless you have measurements, unless you know some things about the figure you're looking at, the triangle you're looking at. So taking a look at where they start here, and I'm just going to read this out loud, especially because the way they phrase it is helpful in the way that the logic is presented. So if two triangles are congruent, it means that all corresponding angle pairs and sides are the same. Alright, cool. And let's just break that down. I'm talking about if two triangles are the same, alright, then all the angles on the inside of both those triangles have to be the same as well. So the angle that A and angle A prime, right, that represent the same part of the triangle, those have to be the same if these two triangles are congruent. Cool. Alright. You don't necessarily need to individually verify that all angle pairs and sides match exactly to be sure that two triangles are congruent. So here's the cool thing. We can deduce some things using our logic, and we can kind of cheat a little bit or get a few shortcuts, right? So, for instance, if you know that if you know the measure of two of the three angles in a triangle, right? So you know like angle A, angle B, you just don't know angle C, all right? There is only one other possible angle, angle C, since all three have to add up to 180 degrees. So, if you know those two the two triangles have two matching angles, then all three angles have to be the same. All right. And if you think about it, right? If I have a 90-degree triangle, I'll learn how to make some drawings here on the screen at some point, but I can do this in class. If you have a 90-degree triangle and you know angle A is 90, angle B is 45, well, hey, 90 plus 45 is 135. So I just have to go up another 45 to get to 180, because every triangle has a 180. You can just deduce, you can just conclude, right, that that other one has to be 45, angle C. We'll do a little example of that in class as well. But if you're following my logic, fantastic. You'll see some more pictures down here at the bottom. So again, like I was saying, you can look at it, but you have to prove it. So sometimes you can look at a picture, and especially on the SATs, they like to do this. They'll put down a picture, and they'll put another picture down near it, and they'll put two different measurements on it, but the pictures themselves will look exactly the same. Alright? And you can't necessarily just assume that they're the same. You have to be able to prove it. Alright? So that's what this is saying, don't be fooled. Alright, cool. So let's look at the angle, side angle. Alright? Basically, take a look at these two triangles. Alright? And I won't necessarily go through the reading of the whole thing now, but let's just take a look at these two triangles. Alright? Angle A here is 51 degrees. Let's go look at this other triangle. Angle D is also 51 degrees. Oh, cool. Interesting. So let's see, what's the corresponding angle to angle B? It's got to be angle E, right? Alright, cool. And then so C, it doesn't matter what that one measures. We just know that's got to be F because we got the other two. Cool. Alright. Hey, so we already identified that these two angles were exactly the same in both of them, right? And it says it right there. And the side here is also the same, so therefore it has to be that AC and AFD are the same, and EF and BA are the same. And even though these guys aren't sitting spot on next to each other, looking pretty next to each other, and it's been rotated slightly, you can still see that these two triangles are congruent. So the angle, side angle postulate will tell you that, yeah, you can prove that those guys are congruent just by looking at it and comparing their corresponding angles. Cool. All right. So one of the ways that we can kind of represent that is by this is not the most fantastic drawing because you can barely see the little tick marks here, but you can sort of see how the angle A and angle D are represented by this single curve. All right, angle B is represented by 2 curves, and angle C is represented by 3 curves. So you can show which one's corresponding. C corresponds to F very easily and visually by just using the same number of curves at each one of the corresponding angles. All right, and then you can also see, if you can really look in, that there's these little tiny hash marks there. All right, and this one would match with this one matches with this one, and this one matches with this one. Cool. So that's basically how you can notate it. All right, so that you can show like this is how this works. All right, cool. Now we're going to look at angle side angle. All right. Actually, we're going to wait for the next video for angle side video. Thanks for hanging in on this one.